Welcome to the high-speed boat building project, a unique miniature edition. 3 boats are powerfully surfing on the river with a perfect aerodynamic steering system, a sports steering wheel system, and a neatly arranged throttle to optimize space. Pre-cast composite seats, and a sleek unibody hull optimized water resistance. Let's start with the V-shaped composite hull bottom. The overall length reaches 2.7 meters. Use a specialized handheld thermal cutter to trim the composite edges precisely. Apply masking tape to shape the outer edge. In preparation for assembling the upper deck, proceed to lay out a thick Fomex sheet, measure carefully, and sketch the basic cut line. Use a utility knife to trim the flange. Adjust the bow's bevel for a perfect seam. The Fomex sheet is bent along the hull's contour
and temporarily fixed with high-speed cyanoacrylate glue. This glue dries extremely fast, helping to shape the load-bearing arch instantly. Construct the inner frame using bent Fomex bars for longitudinal herringbone support. Reinforce with crossbeams to create a solid mesh structure that prevents deck deformation. The main spine of the bow deck is braced in parallel to create a highly aerodynamic water deflecting curve. Apply traditional slat laying techniques to the Fomex surface, gluing each small strip consecutively. This technique allows for the creation of complex, multidimensional curved surfaces at the bow with ease. Use a knife to trim carefully the excess slat edges along the hull, maintaining a smooth curved profile. 4 layers of shell complete the bow compartment,
creating a closed system to prevent water from overflowing. Mark the outline in advance and use a knife to extract the central arch to prepare for installing the windshield later. 5. Splice additional edge trims running along the cockpit rim to reinforce the bulkhead against water tearing. Leo, use a blade to bevel and round the bulkhead edges, optimizing both aesthetics and safety in case of impact. Moving to the stern module, clad it with seamless, flat Fomex panels to enclose the engine compartment. Adjust the stern's tilt angle to fit closely to the deck edge, and apply glue along the joining seams. 1. Bevel cut. 2 symmetrical diagonals to create aerodynamic ventilation slots for the radiator cover. 2. Assemble the folded cross sections at the stern, securing them to create a soundproof compartment and protect the equipment. 3. Sketch and shape the design block for the sports air intake cover, protruding on the stern deck. 4. Fold the Fomex sheet into a sharp, multifaceted polygon and apply glue to shape the covering cap. Insert splints to secure the central groove, ensuring the cladding can withstand wind pressure when running at high speeds. Remove excess plastic with a specialized knife to reveal strong, sporty, embossed ribs. Continue to assemble 2 wedge blocks, triangular, shaping the auxiliary air intakes at the rear. Apply superglue directly to the contact surfaces and firmly attach them to both sides of the engine cover. 4 symmetrical positions on both sides of the engine hatch help optimize the intake airflow to cool the engine block. Use a sanding block to rub and polish the entire deck surface, smoothing out burrs and rough excess glue streaks. Mix the resin-based putty compound with hardener, stirring well to create a uniform, smooth mixture. Use a putty knife to press the putty layer tightly, completely filling the vertical gaps between the Fomex slats at the bow. 4. Proceed to apply putty evenly and continuously to cover the surface, creating a smooth, seamless shell ready for painting. 5. Use wet sandpaper, rubbing continuously to remove burrs and excess putty. Leo, apply a layer of Miracle Gloss Mold Release Wax, evenly covering the entire surface. This wax layer, this carnauba, creates a barrier membrane that helps release the fiberglass mold easily. After curing, cover the surface with a layer of woven fiberglass and use a roller to press firmly so the composite resin penetrates deeply. This process requires meticulousness to completely remove trapped air bubbles for optimal structural integrity. Successfully releasing the mold, we move on to spraying the light gray primer. Using a pneumatic spray gun, a primer layer that helps detect the smallest defects and increases adhesion for the finishing coat. Step 2, spraying primer on the engine hatch. The smooth paint layer adheres tightly to the embossed ribs. Sporty style. Step 3, moving on to the air intakes. Creating a strip effect with a vibrant red and pink gradient that gives a sense of speed. Masking the bow with newspaper and plastic tape. Preparing to paint the black accents. Every strip of tape is pressed down precisely along the gaps to prevent paint from bleeding. Removing the paper masking reveals a sharp jet black pattern tapering towards the windshield. The black and white contrast and red borders create a distinctive design language of a muscular speedboat. Cutting pine wood to make the rear spoiler, hand sanding it to round off the edges. Assembling the modules of the spoiler using a drill to screw the 2 side panels onto the horizontal fin. Applying technical spraying to create a bright red gradient on the spoiler, coating it evenly to create a visual effect. Carefully masking the borders with paper tape, using a utility knife to cut along the curved profile to keep the color band. Taping requires extreme dexterity and determines the sharpness between the 2 color tones. Spraying a thick layer of glossy black paint over the entire spoiler, filling the wood grain to create a smooth surface. Peeling off the border tape. The finished spoiler features a dominant black tone, accented with vibrant red borders. Moving to the interior of the hull's bottom. Roughing the surface with sandpaper in preparation to reinforce the floor structure. Step 4, wiping off dust with a damp cloth to ensure maximum adhesion for the composite resin layers. Bonding it to rib 4, positioning the boundaries with Foamex strips and glue to create a direct pour mold right on the deck. Step 3, mixing polyester resin with a catalyst. The pink mixture starts generating heat and begins curing. Laying coarse fiberglass into the mold, using a brush to soak it in resin, pressing it firmly to cast a longitudinal rib. Trimming the excess burrs neatly. Continuing to apply bonding resin to create mounting points for a sturdy engine mount. Coating the surface with a gray gel coat to protect the structure. This composite is waterproof and resistant to grease. The gray gel coat is rolled on evenly, creating a perfectly smooth surface for the frame system. Under the engine compartment, the rear mount is cast with a sunken T logo, measuring, marking, and drilling through holes for assembly. Assembling the black U-shaped iron locating pads, tightening them with an impact wrench in preparation for the wheel system. Using an impact driver to tighten the U-bracket bolts, creating a solid anchor point for the wheel system. Installing the 2 rubber wheel forks into the brackets, turning the boat into a handy miniature trailer. Securing the rear fork safety latch makes it easy now to launch and tow the boat on land without scratching the bottom. Step 2, installing the omnidirectional wheel assembly into the mount. The black steel V-mount, tightening the screws to secure the axle assembly. Attaching the V-mount to the bottom of the bow. Completing the 3-wheel mobile load-bearing system. Unboxing the Toshiba 235cc internal combustion engine. It has an output of 8.5 horsepower, the perfect choice for a mini boat. The engine utilizes OSV technology for optimal intake and exhaust, equipped with a carburetor and a pull start system. installing 2 black painted wooden blocks on the composite structural ribs to create a shock-absorbing mount that prevents engine vibration. Measuring the position, using a drill bit to bore a hole through the transom to route the shaft, installing the drivetrain to the outside. Step 4. The mechanic drives a steel key into the engine shaft's keyway,
ensuring the flange joint is completely locked. Welding the steel flange to the stern tube to create a tightly sealed grease chamber, absolutely preventing water ingress. Step 5. Chipping off the welding slag and aligning the flange. Placing a paper gasket, made of heat-resistant red asbestos to fit tightly against the engine block. Step 6. Applying plenty of grease to B, the splined shaft. Pressing the asbestos gasket and pushing the stern tube assembly to interlock with the block. Tighten the flange bolts. This coupling assembly is a crucial stopper, preventing water from entering the cabin. Lift the engine and place it into the hull. Align it perfectly. The propeller shaft passes precisely through the rear bulkhead cutout. Tighten the positioning screws to secure the engine block onto the wooden mount. Moving on to the welding process.
The stainless steel tube assembly for the propeller shaft. Grind the weld smooth on the stainless steel V-bracket. This is the protective skeleton for the underwater propeller assembly. Use friction-resistant Teflon bushings. Hammer them tightly into both ends of the stainless steel tube to guide the central rotating shaft. The Teflon bushings help reduce sliding friction and act as watertight seals. For the transmission shaft system, pump in lubricating grease. Thread the inner core shaft into the outer tube. The system is now ready to be connected to the hull. Mount the outer shaft assembly onto the protruding shaft hub at the transom. Weld steel plates together to create the steering rudder. The steel plates are firmly welded to the rotating hub. This is the main rudder, directing the propeller's water flow for steering. 4. Connect the control cable with the blue housing to the rudder arm. The steel core push-pull cable is incredibly smooth. Test fit the propeller and steering shaft assembly. Fine-tune the gaps and the safe steering angle range. Move to the cockpit and drill screws into the A-shaped steel frame. This frame serves as the mount for the steering wheel assembly. The black powder-coated steel frame is firmly secured to the Fomex bulkhead at the bow. Using a screw gun, install the steering wheel's cable winch gear hub onto the mount. It acts as the central hub for distributing steering rotation force. Insert the steering wheel movement hub through the mounting hole. Use snap ring pliers to position the steering gear hub onto the flange. Attach the ultra-cool red and black Momo 3-spoke sports steering wheel. Tighten the hexagonal bolts to secure the flange assembly. Connect the cable to the steering wheel winch base. The steering system now transfers force directly to the rear rudder. Use pliers to tighten the split cotter pin for the safety lock. Connect the steering cable tie rod to the steering wheel base. Adjust the nuts to fine-tune the cable travel distance, ensuring the left and right steering angles are equal and smooth. Install the white hood cover onto the front of the cockpit to conceal the cables and joints underneath. 1. Use a screw gun to secure the front cover with self-drilling screws along the connecting seam. 2. Install the vibrant red fake air intake scoop onto the engine hood. It adds an aggressive look to the hull. San, use an aluminum profile cutting machine to precisely cut the decorative edge trims for the cockpit. 4. Install the horizontal trim panel below the steering wheel, creating a partition between the dashboard and the floorboard. 5. Glue the white curved Fomex trims along the cockpit edges to hide the rough cuts on the hull. Low, apply glue to securely attach the parallel red trims, creating a seamless highlight extending from the bow to the rear. Apply silicone glue to stick the pink trim onto the dashboard. Start flooring the cockpit with Fomex strips. Assemble the white Fomex strips in parallel, completely covering the rough composite floor underneath. 1. Use an Apollo glue gun to pump silicone, filling the connecting grooves and the edges along the bulkheads. 2. Smooth out the silicone lines to ensure waterproofing, absolutely preventing water from leaking into the hull chassis. 3. Move on to assemble the throttle pedal. The throttle pedal is drilled and screwed directly into the white Fomex floor. Route the throttle cable to the rear. Remove the engine air filter cover to access the throttle valve mechanism. 4. Use wire strippers to hook the throttle cable's steel core to the spring that pulls the carburetor's throttle valve. When the throttle pedal is pressed, the cable pulls the throttle valve wide open, increasing the air-fuel mixture into the combustion chamber to accelerate. 4. Proceed to wire the electrical system. Check the circuit continuity using a digital multimeter. Strip the wire casings and use a lighter to shrink the heat shrink tubing to fully insulate the electrical connections. Route the 12 volts power cable from the battery to the ignition switch located on the control panel of the cockpit dashboard. Attach the negative ground wire to the engine block, ensuring the starter motor's starting current operates stably and safely. Screw the ignition switch tightly into the dashboard panel. Insert the key. The remote starting system is now ready. Apply the decals. The bronze reflective decals taper sharply along the sides of the hull, enhancing the aesthetics and cool factor. Installing 2 plastic seats, black wooden-legged AirMax seats, into the cockpit. The seats are firmly secured to the floor. Applying a red and black striped sport decal running along both sides of the hull, giving it a strong racing vibe. Securing a red anti-collision trim along the hull's edge to protect the shell when docking. The jet black rear spoiler with striking red accents combines with the shiny stainless steel propeller shaft below, closing the engine compartment cover. The boat has achieved a smooth aerodynamic design, looking sharp and sleek. Towing the high-speed boat, it moves smoothly on the asphalt road, using the integrated trailer wheel system. The boat is pushed back toward the water's edge near the canal fence, ready for the launching process. The boat is pushed along the dirt road, approaching the water's edge by the fence, ready to launch. The 3-wheel system operates smoothly on the rough wooden planks of the makeshift dock, gradually lowering the bow into the silt-laden water. The composite hull shows excellent buoyancy, lifting the bow, quickly pulling the safety pin to detach the front guide wheel assembly, continuing to loosen the rear wheel axle assembly, completely freeing the hull underwater. The boat now floats perfectly with the stainless steel rudder at the stern fully submerged. The female pilot steps onto the boat, settling into the driver's seat. She turns the ignition key and slowly presses down the throttle pedal. The steel cable opens the throttle, and the Toshima engine roars. The propeller spins fiercely, thrusting water backward. The boat glides gently away from the wooden dock. Increasing the RPM, the V-shaped bow tears through the water surface, cleaving the waves and creating white foam. The camera angle from the bow's point of view shows an impressive sense of speed when gliding past the coconut groves. The cable steering system, combined with the Momo steering wheel, responds extremely sharply to every maneuver. The boat takes a sharp turn, the hull tilting slightly, but maintaining excellent balance, thanks to the engine's low center of gravity. Cutting across the calm river surface, the boat leaves a V-shaped wake, trailing far behind the stern. An outstandingly successful test. The boat turns around and docks safely, with a bright smile from the pilot. The main mechanic boards the boat, switching to a heavy load mode for 2 people to test the propeller's thrust. Despite doubling the load, the 8.5 horsepower engine still has plenty of power to push the boat forward. But the unibody Fomex structure wrapped in composite still ensures an aerodynamic profile,
Water resistance
gliding
increases.
effortlessly. The pilot executes skillful zigzag maneuvers, showing off the flexibility of the rear rudder system. From the opposite angle, the rear spoiler sticks out, acting as an aerodynamic stabilizer. The engine runs stably at high RPMs,
Its crisp exhaust sound echoing across the river. The miniature high-speed boat project concludes perfectly, affirming top-notch mechanical engineering skills.